Hi Science 10. This video deals with Blackline Master 9.7, slope of a distance time graph. So we've been looking at how to figure out speed using distance and time. Now we'll look at a graph, what information we can gather from a graph. Now this graph here has three different types of vehicles: biking, skating, and walking. And since they're all increasing straight lines, they are all examples of uniform motion, as you've seen earlier. Increasing straight lines or decreasing straight lines imply uniform motion. So if we look at this and thinking back into math class, you can see that the biking one, the line has the highest slope, and the skating one has the next highest slope, and the walking has the smallest slope. And you may recall back from math class that when you take the slope of a line, you do that by looking at rise over run. Now, in our case, the rise, which usually in math is the y-axis and the run is the x-axis, so we can say change in y over change in x. That's how we do that. So if we look at each of these lines here, if I look at the biking line first, we can see that there's a run of, in this case, 60. So let's call this line 1 maybe, or let's just call it biking. Okay, so it rises 60, and it has a run of 6. So back to math class, you pick 2 points, and you may have done this triangle idea in which you look at starting off at the leftmost point, and then run and the rise, and that's how we get the numerator part and the denominator part of this. Now, in this type of graph, the rise and the run actually means something. The rise refers to distance, and the run refers to time. The rise is in meters, and the run is in seconds. So we figured that out. 60 meters divided by 6 seconds. So that'll give us 10 meters per second. So, and you may recall that meters per second, of course, is speed. So the slope of a distance time graph gives speed. Now, by looking at this, largest slope, largest number, largest speed. So the skating line has a much smaller slope, which will mean it'll be a much smaller speed, because slope means speed when you have a distance time graph. So let's take a look here. Skating, if you look at that, so it has also a run of 6, so that would be 6 seconds. And this time the run is 20 meters, because I'm looking at this line here. So run and the rise stops there. So 20 divided by 6, I think you get around 3.3 meters per second. So you can see a much smaller speed, much smaller slope. Lastly, looking at walking, if I pick this point, and now in all of these cases I just picked the first point here, 0, 0, and the last point to make it really easy to count. So here, starting with this point, a run of 6, and a rise of, it's just under 10, but we'll just call it 10 just for simplicity here. So it'll be 10 meters divided by 6 seconds. Of course, it's half as great as the other one, 1.7 meters per second. So smaller slope, smaller speed when you have walking compared to skating. Okay? So this is true with the distance time graph. It'll give you speed. So you can make that little note there, put a few stars there, because that's what it results in. Rise over run, meters over second, that's speed. So moving down here, you can see this calculation here. This deals with what? The travels of a Hummer. So we're looking at a vehicle going in so many kilometers in so many minutes. So kilometers over minutes, kilometers per minute will be the speed unit there. And of course, from math class here, slope is equal to rise over run. And of course, rise over run we know is rise over run. You may have done this in math class. Change in y over change in x. Okay? And of course, to figure out a change in something, it's a final y value minus an initial y value, or a final x value minus an initial x value. So when you're picking 2 points, and if you don't pick 0, 0 is one of the points, there's a little more work involved here. So for example, if we have point number 1 and point number 2 somewhere around there, we can see that you go over 2 and up 2. So we would say 2 comma 2. And of course in math class you may have remembered that as being your first x point and your first y point. So x1 comma y1. Over here at your second point, go over 9 up, what is it, 9 as well. So 9 comma 9. So that's going to be our second x point and our second y point. x2 comma y2. You likely did this in math. Because to figure out this distance, we need to figure out that whole distance, subtract this little amount will give you that. And to figure out this distance here, we have to take the entire 9 minus this little section, and that'll leave us with the section we're looking for. So, and of course that's what they do here. So to figure out, now I've noticed here that they reverted back into what the graph actually represents. Our y-axis is actually d. Our y-axis is actually d. And our x-axis is actually time, change in time. So we can say that, to figure out the change in distance, second distance minus first distance divided by second time minus initial time. So we reverted back into the equation, and we can see here that the math method of figuring out slope is the same thing as using the formula that we looked at earlier. So plugging those values in, d2 minus d1. Now if we go here to make it easy here, our x here represents time, so that's actually t1, d1. And here we have t2, d2, not to be confused with r2, d2. So if we take a look here, d2 minus d1, 9 minus 2, and then t2 minus t1, 9 minus 2.